Okay, we're going to pause the video here in a moment for you to write down these 3 problems and try them. And then once you're finished, we'll unpause it and you can watch me doing the solutions. So for number 1, I'm going to change this to an exponent because now when I multiply these powers, we get an exponent of 1/2. So that's just the square root of 24. So if we break 24 down, that is 4 times 6. We know the square root of 4 is 2, and we're left with root 6. For number 2, I'm going to split my exponent. Because now 9 to the 1/2, that's the square root of 9. That's 3 to the 5th. And then for number 3, because of the negative exponent, that moves to the denominator. And then what times itself 4 times 16 is 2. These are the homework answers from last night. Make sure you check every night on Edline. If you have any questions or you want to go over any of them, you can save your questions for tomorrow, or you can go to Miss Strauss or Miss Balfour at lunch, and they will be happy to answer your questions. Okay, so today we are going to solve equations with rational exponents, and then we will multiply radicals. So our first part here is solving. So just like when we had quadratics first semester, we want to isolate the variable with the power. So for number 1, we want to isolate the x to the 3rd. To start, I'm going to subtract 1 from both sides. Divide by -4. So now, to move this exponent, I'm going to raise both sides to a power, and what I want to get on the left is x to the 1st. So you have to think to yourself, what can you multiply 3 by to get 1? So if we take the multiplicative inverse 1/3, you are always going to take the reciprocal to multiply to get 1. So these powers multiply to 1. And now -3 to the 1/3 does not simplify. Nothing times itself 3 times is -3. So we can leave our answer just like this. You must have these parentheses around the -3. Another way you could write your answer is the 3rd root of -3. Because the denominator of the rational exponent that we chose was odd, I do not need plus or minus. When we get down here to number 3, we'll talk about if we do need a plus or minus. Okay, so now for number 2, write that equation down. Subtract 1 from both sides. Divide by 2. And now, to eliminate the exponent, we're going to raise both sides to the 1/5 power. Because the denominator was odd, I do not need a plus or minus. But one last step, we're going to add 2. So our answer is x equals, let's do it as negative 4 to the 1/5 plus 2. Could also be the 5th root of negative 4 plus 2. Since order doesn't matter, I could put the 2 before the radical. Any of these forms of the answer are appropriate. Okay, so now here for number 3, we're going to isolate the term that has the exponent. And then we're left with 3 times x plus 5 to the 4th equals 10. We're going to divide by 3. So that's x plus 5 to the 4th equals 10/3. So now we're going to raise both sides to the 1/4 power. Because this denominator is an even number, when I write my next step, I need plus or minus 10/3 to the 1/4. And then to finish, we'll subtract 5 from both sides. So let's do negative 5 plus or minus the 4th root of 10/3. For today, you may leave this fraction underneath the radical. Tomorrow, we are going to learn how to simplify this, but for today, it's fine. Let's talk about why we need this plus or minus with an even denominator. If I have this problem, x squared equals 16 versus x to the 3rd equals 8, I know that the possibilities here could be 4 or negative 4 to square to get 16. So with our new topic of rational exponents, what we did was we raised both sides to the 1/2. That's an even denominator. So if you have an even denominator, you must have plus or minus. Now when it's the 3rd power, the only number that multiplies by itself 3 times to make 8 is 2. If we had the x to the 3rd equals negative 8, then that answer is negative 2. But they're both separate. Like each problem will only generate one solution. So if you have an odd denominator, like this 3, there is no plus or minus needed when you're solving. Okay, so now we're going to talk about multiplying radicals. We're going to pause the video here for you to write down these rules. These are going to be our guides for doing the next problems. Okay, so for problem number 1 here, it is the same radicals or the same power. So this is a B situation. We can multiply or divide the bases. And 16 times 4, 64. But now we have to simplify that. So what times itself 3 times is 64? Well, actually, what I could have done is taken this 16 and said that's 4 times 4. And we have this 30. So that makes our answer 4. The same bases, so that's an A situation. And to apply the laws of exponents, we have to first change the radicals, so they're exponents. And the law of exponents, when you have the same bases and you're multiplying, means we're going to add our exponents. So 1/3 plus 1/2 is 5/6. If you need help adding fractions, make sure to see me at lunch. Common denominators. Okay, so for situation 3, they have the same radicals and the same powers, so we're going to divide the bases since it's a division problem. So that's a B situation. So that is the fourth root of 16. And now what times itself 4 times is 16 is 2. Number 4 is the same setup. We have the same radicals. 250 divided by 2 is 125. What times itself 3 times is 125, and that is 5. So we'll pause the video here for you to try 5 through 8. Okay, so for number 5, we have the same bases, which means we're going to apply the law of exponents. So we're going to add 1/2 and 1/4. That is 3/4, so our answer is 5 to the 3/4. What I should have said in the very beginning, I'm sorry I didn't, if your problem starts as fraction exponents, you can leave your answer as a fraction exponent. If you get to something where it's a radical that can simplify, you should definitely simplify. Somehow my answer for number 1 disappeared. And then what I should have done for number 2 is, because I started with radicals, I should end my answer with a radical. So I'm going to rewrite this as 6 root of 6 to the 5th. Okay, so for number 6, you have the same radicals. So I'm going to divide my bases. And then what times itself 4 times is 81. That's 3. Now for 7, on the inside of the parentheses here, we have different bases and we have different powers. So technically that's C, but first I'm going to handle the whole quantity to the power of 2. Because it's a monomial inside, I can use this power of 2 to both terms. So when I multiply 1/2 times 2, I get 1. And then 1/3 times 2 is 2/3. And that's going to be our final answer for 7. Okay, and for 8, we inside our parentheses with the division, we have the same radicals or the same powers. So I'm going to divide the bases. And then the last step, I'm going to simplify by multiplying my exponents. Okay, so here's 2 final problems. I can pause the video for you to try these. For 9, I'm going to put a power of 1 in the numerator so that it holds my spot. Because I have the same bases, I'm going to subtract my exponents. We get 7 to the 2/3. And lastly, I don't like that negative exponent in 10, so I'm going to move the whole quantity to the denominator. And then inside, the powers are the same, so I can multiply my bases. And then I can now multiply my exponents, because for the law of exponents, and I get 6 to the 1st. So our answer is 1/6. Okay, so now your homework is worksheet 7.1c. Start that with the time remaining in class, and make sure to check your answers on Edline.